No, he's on second.
I don't know. I know he's on third.
Google Abbott, this is what you can use your technology for. Google Abbott and Costello baseball, and
It's one of
the greatest.
Have you seen the one down the ship and they do the baker's dozen?
Yeah.
That's a great one too.
Yeah. Okay, who's on top? You said, let's pick a number and evaluate it. By the way, because we didn't have any crossover, you can pick any number you want to plug in. Why not? Now, if there is crossover, we need to pick a number that's inside the zones to see which one's on top, but here the zone is infinity. So if I try f of 0.
Also, we have to pick things on both sides because we don't know if they just touch or if they do cross.
Right, yeah, because you don't, just because they do hit each other does not mean that they actually cross over. All right, what is f of 0?
F of 0, 10.
10. What is g of 0?
0.
0. So who's on top? F. All right, very good. Yes.
I was about to say first.
F is on top. So when I set up my integral, I will do f as the first one and g as the second one. Let me point something out. 0 is not inside our zone. However, we just figured out that the zone technically was infinite as far as one function being on top or the other, so we picked our favorite number. Love 0, either 0 or 1, those are my two favorite numbers. If you have a crossover inside the middle, which we'll do in the next example, then you'll need to check maybe more than one zone. So my integral, finally, okay, my integral is going to be the antiderivative from 1 to 3, that's the zone they want. The f function on top. Okay, f for us was x squared minus 4x plus 10 minus the g function on the bottom, 4x minus x squared. Notice how many parentheses and brackets I have in this problem. That's about how many you would need. One to isolate the f, one to isolate the g, and then one more around all of it to say everything is inside the integral. So please don't skimp on your parentheses, brackets, braces, whatever. All right, here we go. 1, 3. Let's do some arithmetic first. By the way, you can take an antiderivative with all 5 of these pieces if you want to. It might be nicer to clean it up a little bit first. Okay, we have an x squared. Oh, I am so sorry. We do not have an x squared. We have a 2x squared. We have negative 8x's, and we have a 10. And that is about as clean as I can get it without taking an antiderivative. So, here we go. This is going to be 2/3 x cubed, antiderivative, minus 4x squared plus 10x from 1 to 3. 3 is slightly annoying. The 1 is easier to plug in, but it gives us a more irritating answer. All right, 3. One of these 3's are going to cancel with that 3, so we get a 9 times 2, which is 18. 3 squared is 9, so minus 36 and plus 30. Now we're going to stick in 1, excuse me, and get 2/3 minus 4 plus 10. It is really up to you how your brain works with arithmetic, but whatever. This is 48 to me. 48 minus 36 is 12. That's 6. But we're going to be subtracting it, so 12 minus 6 is 6. And that only leaves this little guy right here, minus 2/3. Which is 5 1/3 or 16/3. And again, I don't really care how you get to that conclusion. That would be, for multiple choice, they would write it as 16/3. Free response, you could write 5 1/3 if you wanted to. We don't really do that at our level, but you're more than welcome to. Now, we did way more work than we needed to on this problem, but only because we didn't know they met each other. So you will need to take the time to see if they intersect, which will affect the points you plug in to see who's on top and who's on bottom. After that, it's good old calculus the way that we are used to. Okay, so think of this right here. If we need to split this into multiple pieces to account for multiple regions where different things are on top and bottom, then do that. All right, how do you feel? Pretty good?
I'm doing great.
Yeah. You what?
I'm doing great.
Yeah, okay, what do you watch this? Oh, yeah.
It's just so good.
Is he watching it?
He's watching it on first, yeah.
Okay.
If we have some time at the end, we'll crowd around the old laptop and
It's so good. It's one of the best.
Maybe that'll be the first time we use that technology in this class.
It's old 60s.
Wait, I'm copying it.
Did you just?
Aw.
Oh.
I don't know when they came out, but it's classic old comedy, which
Oh,
makes
yeah,
you laugh.
still black and white. What did I put here, 6 minus?
I don't remember you erased it.
I think I did. There you go. All right, while you are still copying, I will set the stage for another fantastic example. All right, here we go. Here we go. And they would, of course, wrap some wording around this, like, find the area enclosed between, okay? Or find the total area enclosed, they like those words.
Do they really?
They do.
Okay.
Yada, yada, yada. So if you're looking for verbiage like that, find the total area enclosed between, blah, 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 blah. By the way, you can do this. You could just do f minus g from 1 to 5, plug it in, get an answer. It'll be wrong, but you can do that. Area like this is never negative. It is area that we have trapped, so all that area is going to be positive. If you get a negative answer, that's a dead giveaway that you probably got it upside down. Or if your number comes out a lot lower than what you think it should, then that means you've got some area trapped one way and then some area trapped another way, and they're canceling each other out. So this is why we need to split it if at all possible. All right, step 1, intersection points. And I hope it's not as boring as it was last time where we didn't have intersection points. It's not.
Is it easy?
So if we set them equal, we get x squared minus 5x minus 7 equals x minus 12. Okay. Equal?
Yeah.
Am I good? All right. X squared minus 5x minus 7 equals x minus 12. I'm going to bring these two guys over here, set it equal to 0. So I get x squared minus 6x plus 5. Is that right? Equals 0.
Yes.
And that factors beautifully into x minus 1 and x minus 5. Is that right? Make sure I copied this one right. Nope, I did not. -2. I was thinking ahead to something else, but here we go. Which gives us intersection points at 1 and 5. That's what I was thinking of. Okay, unfortunately, I don't know just because they met which one of those is on top and which is on bottom. If you're really good at graph theory, like if you could look at those equations and picture them, then you kind of know which one's on top and which one's on bottom, and what zones they are. You have a parabola that's going up and you have a line with a slope that's positive. If they're going to meet twice, I know exactly what's happening. I know exactly what that looks like. Until you get good at this, I would say use some test points.
One way to guess is, X is going in, it's the parabola, so it's going to go up and hit it, and then come down and hit it.
Everything to the left of 1 is going to be f on top, g on bottom. Everything to the right of 5 is going to be the same thing, and in the zone in the middle, 1 to 5, the line is going to be on top. If you can picture that. If not, no big deal. So let's see which ones are top. We actually have 2 zones.
In the middle,
That's it.
the parabola should be on top. Oh, no, parabola.
There you go. We only have 2 zones. We have the zone from -2 to 1, and we have the zone from 1 to 5 because that's where they've cut us off in both places. That's where they hit, and that's where they've cut off the zone. So let's talk about zone 1, from -2 to 1, and who would be on top? Give me a number in between there.
0.
0, sounds good. So f of 0 is -7. G of 0 is -12. F's on top. Let's do the zone from 1 to 5. F of 2. Alright, we'll pick that number. F of 2, we've got -17 and for -13. And G of 2 is -10. That one's on top. So we will have to set up two separate integrals for this one for the F on top, one for the G on top. Most of the work is going to be exactly the same.
Except you just have to do it twice.
You'll just, well, it flip-flops, is all, the equation flip-flops. So here's how it would technically look long way. We got zone number 1 from -2 to 1, because that's where our first stopping point happens, where they meet, okay? And in that scenario, F is on top, and G is on bottom. Then, we're gonna do the second zone, which goes from 1 to 5, where G is on top, and F is on bottom. By the way, you can finagle it like this, if you really want to. Notice how these are not the exact same thing, but they are opposites of each other. If you want to keep it exactly the same on the inside, you can do this. Leave this one the way it is. If you flip-flop this one, we know our area is going to come out backwards, so we could just put a minus sign here instead of a plus sign, and it would take care of that wrong sign answer, if you want to do that.
That's a fun word,
What?
finagle.
Finagle, it is. You've got me thinking now about fun words.
I'm sorry.
Gotta stay focused, stay focused. All right, we have x squared minus 6x plus, wait, minus 6x. Did I do that? Yeah, x squared minus 6x plus 5 dx. And then this one's gonna go from 1 to 5, it should just be the opposite, -x squared plus 6x, and then minus 5. Yeah, okay. So the integrals will be exactly the same, just flip-flop the signs. So number 1, 1/3 x cubed minus 3x squared plus 5x from -2 to 1. And then the second one is going to be the exact opposite of this, so -1/3 x cubed plus 3x squared minus 5x. And evaluate that one from 1 to 5. All right, here we go. Use some of that. 1/3 minus 3 plus 5. Then we're going to minus, or subtract minus, it's retarded. -8/3. Minus 12, minus 10. And then we're going to add in this second chunk of area, which is -125 over 3. That's 3 is 75, minus 25, minus whatever we get when we stick in 1. What do we stick in 1? -1/3 plus 3 minus 5. By the way, these two areas do not cancel each other out. At first glance, it looks like they might, but that minus sign changes things. All right, let's see here. This is easy. Okay, that's a positive 8/3, and a 1/3 makes 3/3. I'm sorry, 9/3 or 3. That 3 is going to cancel this 3, so we get 5
Minus 22.
plus 22, so 27. All right, over here. 50 That's -2, so it becomes +2. 52, 52. And then that's -125, that's a +1, so -124. Excuse me, common denominator here. My goodness, is 3, so 156. Is that right? Yeah. 156 minus 124 over 3, so 32.
32.
Plus 32 over 3. Okay, common denominator is again a 3, that's 81. 81 and 32 is 113. 113 over 3. And I'll leave your arithmetic skills to the test if you want to check that. One line of calculus, a whole buttload of algebra. You kind of have calculus here with the setup, but there's your one true step of calculus, and then the rest of it is just a ton of arithmetic. They would not accept this as an answer, by the way. They would want you to clean it up. Now, how much you clean it up and what it looks like is a little vague. That's just too much to leave. That's even irritating because you're doing an improper fraction with a whole number. They would want you to either turn that into a mixed number and combine it, or do kind of what we've done here. They frown on this a lot. All right, ladies and gentlemen, there's the crux of it, area between two curves. Graphically speaking, this is what we had. It looks something like this. You've got your line, which looks like this. And then you have your parabola, which does something like this. Okay, and I'm just making up numbers here. This is the -2 zone right here. Here's 1, and here's, let's say, 5 right there. So you found this area, and then here's where we crossed over and we found that area right there. Right? And all together, it's 113 over 3. That is not canceling out. If you do it as one giant -2 to 5, you'd have canceled. This would be considered positive area, this would be considered negative area, and they would knock each other out. And that would be way too small.
On the line, what determines negative and positive area? What like?
What do you mean?
Because on what considers negative positive, that is your first is your
Top function.
top function.
Right.
Okay.
You're talking about like this, some of this area is below the axis, kind of
Yeah.
thing?
Well, I don't know how, like, just because, like, we're saying that top is positive and under the under that F function.
If you treat it as two separate individual, like we don't even worry about the line, we just do the parabola, then your cutoff is the x-axis. Stuff above the x-axis is positive, stuff below the x-axis is negative. When you word it like this though, when we do top function minus bottom function, we're essentially moving the whole graph up so that it sits on the x-axis. It would be like flattening this line out to create that kind of area. I mean, it's, what we do is way more simple than that, but that's essentially what you're doing is flattening it out. All right, and I think tomorrow, I want to save the next example. Yep, all right, so we're gonna hold off there and hit the ground running with both feet tomorrow with some really, really interesting examples tomorrow, okay? So we'll pause there, go ahead and do the turn off button. See you next week.
Where is it at?
It's in the back, or it's, that was Sloan's head. That's
Behind.
still Sloan's head.
It's the silver button.